classes before CAT examination, we were discussing about the pattern association. How to associate the patterns, how to associate how to perform auto association, how to perform hetero association, what are the networks for that, including the half-field network, bidirectional associative memory network, and of course, before that we have seen auto associative memory models, hetero associative memory models, then we have seen half-field networks, then we have seen bidirectional associative memory networks. Remember, we have made with some simple examples that are there in the book, and we have tried to play with those examples and understand the behavior of these networks. While concluding that particular topics, we also said, look, there are certain metrics that includes the Hamming distance, then the network capacity. Then finally, before we conclude, we said there is a function called energy function. So for every associative memory network, there is a function called energy function, right? There is a function called energy function. So the energy function has a lot of philosophy. Explaining that itself will take a lot of time. The point is that those who are really interested, maybe I will share a couple of links. Please go through that. Typically, the energy function is a function which is determining the stability property of the network. Okay. So the function determines the stability property of the network. So we define the energy function for bidirectional associative memory. We define the energy function for the the half-field network and all that. So essentially, it is a non-increasing function. Okay, basically it is a non-increasing function, and it's also called Lyapunov function. Okay, so you can write it as Lyapunov function. Okay, it's also called as Lyapunov function. Essentially, how we are going to do this particular the network energy function is that it is like this. So we have the state of the system. Generally, the state of the system is how do you define the state of the system? Is the state of the system is the vector of activations. Okay, of the units. Right. Now remember, when I say vector of activations, when you look at the auto associative memory model or hetero associative or bidirectional associative or half-field, the vector associations typically we have seen in the case of both input vector, input, and as well as testing. While doing the testing, in case of auto, we have, in case of hetero, we have seen the noisy patterns also, right? So when I say state of the system, typically it is the vector activations of the units of the network. So what typically we do in terms of calculating the energy function of a given network is that we verify the energy function of the network E is equal to minus 0.5 to X W transpose and X transpose. Okay, so typically when you give, when you want to calculate what is the energy state, energy of the state of the your system, so you take the input pattern. For every input pattern, you calculate. So take an example, you have X1, you have X2, you have X3 and so on. So for every input pattern, we calculate the energy value. Okay. We calculate the energy value of X1, energy value of X2, energy value of X3. How do you calculate? So energy is equal to minus 0.5 into X to W transpose. We all know that the weight matrix in the case of associative memory models, the weight matrix is the one which represents the memory. So W transpose into X transpose. So though I have written here small x, you can regard this as the vector. So you can think it as x1 in case of the x1 vector, W transpose x1 transpose. Okay, so E is equal to 0.5. x1, x2, x3, and energy value of all the vectors, corresponding energy values of all the patterns. Now we have test patterns. Okay. Imagine the test patterns. When you give x1, obviously the corresponding energy value would be equal to the energy value of the x1. But the point is, imagine you give the noisy x1, okay, or partial x1. You allow the network to get trained, right? This is where you can see the decrease in the energy values and get stabilized. So when you present an IC or a partial or incomplete, okay, whatever you call, IC or partial or incomplete test pattern, obviously you expect that network has to converge and retrieve the corresponding pattern, right? Say take an example, I am giving the noisy pattern of x1. You expect the network to return the stored pattern of x1. So when you take the noisy pattern of x1 and calculate its energy value, then when allow the network to converge as per that particular corresponding algorithm, say whether it is a BAM algorithm, whether it is a half-field algorithm, when the units gets converged, you're going to retrieve your x1. Then you calculate the energy value of the system. Obviously, you get the energy value of x1. So from noisy x1 to get the energy value of x1, what happens is the energy values gets decreases. That is the reason why you call it as a non-increasing function, energy function, and the energy function is given as this one. It is to understand the energy function philosophy is that you need to understand that the associative memory models are basically stable models, and you define the stability of that network through the energy function. Up to here you understand, but there is a lot more to know about the energy function of the associative networks. Those guys who are really interested, they can I will share the links and you can read it and then learn it. So that means given a particular problem, whether it is a associative memory problem, the bidirectional or a half-field problem, so typically what you do, you take the input pattern. For every pattern, you calculate the energy values and keep it aside. Now, when you are testing the network, for the test pattern also you calculate the energy values using the function that is given on the slide or the this one. And remember, this is the short version of the energy function. There is a lot more bigger energy function, and this is a shortened version. So the point is, when you calculate the energy function for the input patterns that are used to create the memory, then energy patterns, energy function for the the noisy patterns, when you using for the testing purpose, you can notice that the energy values have come down, and finally they get stabilized to be the same. Okay, because the network is converged. Okay. So we have seen the parameters. One is the stability property through energy function. The other day we have seen the Hamming distance. Then also we have seen the storage capacity of the network. So that's all with regard to your the memory models. So if you notice in the syllabus, so far we have completed these points, right? I'm just going to keep. Give me a moment. I'll just take it. So we have finished module 1. Look at the So if you note, okay, I think it's gone. So we have finished your module 1. We have understood the various neural network models and all that, and now we have completed the memory models also. Right. So that comes to the end of your module 2. The next one, we have another interesting network, which is module 3, that is the unsupervised networks. Okay. So far, whatever we have or whatever we have seen, typically in the case of training and all that, essentially we focused on supervised environments. Right? So now what we are going to discuss is unsupervised networks. Okay, as the name itself is mentioning, the unsupervised networks. Can you somebody tell me what was that meant by unsupervised network?
So basically there is no target
It do
area.
not have target.
So when you look at the training algorithm, you do not find there is no target. Okay? No target vector or no target pattern, or we will not have any kind of environment which gives you a kind of a feedback or a entity. So the unsupervised networks, typically when you notice, there is no feedback. Okay, in terms of even if you look at the back propagation, there if you notice, you have the target fixed. Okay, fixed at the output layer, but not at the hidden layers. But then what is happening? Your output layer is propagating or giving the feedback, right? In terms of what is the error. Okay, in terms of error. If you look at the unsupervised networks, there is no such kind of propagating error backwards or providing a value such as target, or there is no desired output. Right? These are all makes the particular network as unsupervised network. Okay, so the responsibility of the network is much more here, in the sense that the network itself should discover. Okay, the network itself should discover any relationships. Okay, remember, this is any relationships of interest, or features or patterns or correlations. You see several things, or categories. Okay, the network itself should discover. So typically, okay, now we have a class going on. There are about how many students are there? Around 60, around 50 or 60 students are there. Now imagine I'm just saying form two groups. I'm just saying form two groups. What you guys will do? Hello? Hello, yeah? Okay.
Yes, sir.
Yeah, tell me what you guys will do. Imagine if I am asking, say, take an example, Medha, are you there? Is
Hello.
Medha there?
Yes, sir.
Medha, are you there?
Yes, sir.
Amma, Medha, if I am asking you, form two groups, how do you do it?
Hello.
Yeah, is it audible, Medha?
Sir, you are audible. Am I?
No. Yeah, there is. Yeah. So please tell me. Imagine there are about 50 students in, or 60 students in, 52 students are there in the class. Okay, leaving myself and Mr. Subramaniam, there are 50 students in the class. Tell me You have to form the groups, two groups. What you will do?
I'll just divide them into two, sir. Like the number of people divided by two, and then like.
What is this? I'm saying, I'm not asking you to divide the number. I'm saying form the groups. How do you form the groups?
I like, is that has to be based on something?
No, see, that and all I'm not telling. I am just saying form two groups.
I don't know, sir. I would just do the number divided by two.
Okay, then how you tell me where you will, which group you will go. See, form into two groups.
On random.
See, no, see what? There is nothing like random, madam. No, it's not random, right? Okay, there should be some basis for your grouping. You cannot say, okay, I'm making it random. I'm not saying that do it randomly. Have some basis and do divide into two groups. Okay, no issue, don't worry. We will go to Piyush. What you do, Piyush?
Yes, sir.
How do you do it?
Sir, one criteria can be like we can take the registration number and like one we can just put it into basket, like one in one and the others in two, till that like all the registration number are given.
That's what Mehta said. I said you are saying randomly you will pick this guy and drop here and that guy drop here, that like that.
No, sir. Like we will first arrange those registration number and then we will do like that.
Okay, fine, very good. Anything else?
So directly first 25 registration numbers and then next 25 registration.
Okay, anything else?
Odd and even. Last digit odd in one group, last digit even in one group.
Very good. Anything else?
Gender.
Very good. So, so this is what is expected, right? You need to follow some logic here. Being a computer science student, there should be some logic or a criteria based upon which you are forming a group. Somebody may say that, look, I am forming the group based on the gender. There are a set of male students goes to one group and set of female students goes to one group. Somebody may say that, look, I'm taking the registration number and the registration number, all even registration numbers will go to one group and all odd registration numbers will go to another group. Remember, I am not telling you what is the criteria. If I am telling you the criteria, then it is supervised. If you guys follow a criteria, that becomes unsupervised, right? Hope you are following it. Hello?
Yes, sir.
Yes,
You
sir.
decide,
Yes.
you decide during the categorization process. You pick the pattern. Okay, first pattern. Okay, this is so and so registration number. Male student, push it into one group. Next set is coming. Female student, push into another group, or odd registration number, put into another group. Something like that. There should be some criteria, and the criteria may even get evolved. But the point is that I will come to that point. What is the criteria when it comes to forming the group or forming a cluster or forming a category or forming a your cluster or whatever it is. The point is that if you observe what I have written on the slide, the network itself should discover the relationships of interest. I just said what? Form two groups. I may even say that, look, I'm giving you the same sample, asking you guys to form, say, 10 patterns, 10 clusters or 10 groups. I'm saying just 10 groups. I'm saying 5 groups. So my responsibility is that I decide about telling, look, I want 5 groups. And it is the responsibility of the network to discover the relationships of interest or features or patterns or categories or correlations in the data and allow the network to learn, then converge. So the beauty of these networks is, these networks or unsupervised. Hope you guys have got the point. Right? Hello?
Yes, sir.
Yes, sir.
Yes.
Okay.
So the point is that once you do this, now the point is you have done, so we have about 50 students now. So you made the network done. Now the point is you have a new feature. Okay, the 51st feature is coming. Okay, so leaving myself and Mr. Subramaniam, you have done the grouping among the 50 students. Now a new feature is coming. So okay, imagine somebody has said that I followed gender basis. So then what you do, this new feature, you need to understand what is the similarity of the new feature with the scene patterns. I'm just writing it as scene patterns. What are the scene patterns? There are about 50 patterns that are seen by the network and learned by the network and formed it into the group. And then when the new feature comes, based on the learning on the scene patterns and finding the similarity with the scene patterns, you are going to push this new feature to a one among that groups. Hope you are able to follow. Understand?
Yes, sir.
So when the new feature comes, there are about 50, as I've said, I have given you 50 samples. You allowed the network to converge. The new feature is coming. When the new feature comes, the new features similarity with the scene patterns that are already seen by the network. That means the 50 patterns that were seen by the network. Based on that, you are going to find the similarity of the new pattern and allow that new pattern to settle in among that particular, whether it is a 2 group or a 5 group or a 6 groups or the 10 groups or whatever it is. Okay, that's how these networks behave or the networks work. Okay, is that clear?
Yes, sir. Yes, sir.
And the point is, when you do this activity, now take an example, you have the new feature coming in. When the new feature comes in, as I said, let us take the the two categories, or two groups, or two clusters. When the new feature comes in, what we are doing, we are seeing the similarity of the new feature with the scene patterns and saying that this new feature is going to that one of that particular group, one of the particular cluster. That means what is happening? Among the final output nodes you have, one among them is giving you an output, right? Have you got the point?
Yes, sir.
Yes, sir.
That means imagine you have two groups. I said form 50 students, form into two groups. You made two groups. 50 students, 50 sample patterns you have trained. Now a new feature has come. When you have a new feature, when you calculate the similarity based upon the scene patterns, this new feature will settle down to one of the categories, right? Either first category or second category. That means your one of the neuron will give you an output, correct? So when you have one among them is giving the output, means what? One among them is giving the output, or one among the nodes, or one among the groups is producing the output, or providing the positive output. What does it mean? It means that it is the winner node. Okay, you call that node as the winner node. So when you will have the winner, when there is a competition. So unsupervised networks are also called as competitive networks. Okay, why they are called competitive networks? The reason is that when you provide a new feature, of course, I am giving the explanation or illustration with the help of new feature, not only with the new features. Imagine you have 50 patterns, you are training the network. One among, whenever you submit a new sample, that settles down to one of the group, right? So that group is the winner for that particular pattern. and hence it is called competitive network. Okay, and of course there is there is a lot more illustration need to be done when I say competitive network. It depends upon the network architecture also. So that means in the unsupervised networks, okay, so essentially in the unsupervised network, you also call it as competitive networks. Okay. Competitive networks. Here, only one neuron in the competing group will possess a non-zero output signal, okay, at the end of computation. Rest will have zero signal. Is that only one neuron? Again, it depends upon the network. Say take an example. It depends upon the network. Say take an example, you have a self-organizing network such as coherent self-organizing map. It's not only the one neuron, even you can decide or fix the radius. So that particular winner neuron and also the corresponding radius of neurons will also provide the output. So that depends. But essentially in the competing group, only one neuron or else the radius of neurons, depends upon the architecture, will possess the non-zero output signal at the end of the computation. That's what is called competitive network. Okay. Now in the competitive networks, you have various varieties of networks. Okay. First one is called MaxNet. Okay. The MaxNet is MaxNet or Mexican hat net, then Hamming net. These are all one category or one variety of a competitive network. So basically these are all elementary in nature, okay, and they actually do not require any training. When you say that there is a training, what is happening? Can somebody tell me? When you say that there is a training, what is happening?
So we are modifying the weights.
So when I say that there is no training, do not require any training, what does it mean? It means your weights are fixed. So your weights are fixed and they are predetermined. Okay. So one variety of network called MaxNet. There is another network called Mexican hat network, another network called Hamming network. These are all elementary competitive networks. They do not require any kind of training, and these networks weights are predetermined and fixed. Then you have self-organizing maps under the name called Kohenen self-organizing map, because it was invented by Dr. Kohenen. So it's called Kohenen self-organizing maps. Typically, their responsibility is to, it groups data. The purpose is to group the data into various clusters, and it is the best one of the best model to portray your unsupervised learning. Okay, whatever we said about unsupervised learning in the previous the screen is this one, and this is it seeks to find patterns, regularities, etc., and all that. Okay. Then you have third variety of network called LVQ network. This is actually a typical network. This is actually supervised in the sense that it avails training patterns. This is a one peculiar network, LVQ network. Then we have ART network, adaptive resonance theory network, ART network. This network, they are also meant for clustering purpose. Okay. So these are the various varieties of competitive networks. So when we look at your syllabus, we have seen we have self-organizing maps, LVQ network, and ART network. Okay. So we will be discussing these networks in the syllabus. Okay. Now, when we look at the, I think we are closing to 6:40. So maybe I will pause here, and tomorrow I will continue the. Tomorrow I will start the MaxNet because we need a full class. So that I pause here, and we will continue our discussion tomorrow. Okay. So any doubts